Well, thank you for coming here today. My name is Jordan Adler. I'm an engineering director at OneSignal. I've come here today from San Francisco to get to share a little bit about some of the techniques that we use more on the cutting edge to build really amazing products in a very fast and efficient way. You know, when you're a startup, you don't have a lot of time. You don't have a lot of people to build stuff. And you have to be fast, you have to be scrappy, you have to be smart, and you have to be smarter than the competition. And so this slide talks about some of the techniques that we use to be smarter than the competition, specifically around API client libraries. So I'll dig into that now. And the core of what we're talking about is generating API client libraries from an OpenAPI specification. And I work for OneSignal, and let me tell you a little bit about why we needed to do this, because I think that's really important. So what we do is we're a kind of a customer messaging service. We provide infrastructure for app developers to put us inside of your app, and then your push notifications, your email, your SMS, your in-app messaging, all of that transactional stuff like your order has shipped, your order is on the way, your order has arrived. But also the promotional stuff like 10% off your next order, right? All of that can come through the same pipeline. And we have a dashboard that marketers can go in and use our website, and developers don't have to change anything, right? So in the past, for example, if you had an iOS app and Halloween was coming up and you wanted to do a Halloween special pop-up, it's a Walgreens app, come to the drugstore, buy some candy, it's on sale. Your your marketing team would design it, your iOS developers would code it out, you would send it to Apple, they would look at it maybe a week later, they would say, it's wrong, you're wrong, everything you do is bad, you need to go fix it. And then it comes back and it's a whole process. But with our system, they're able to just have the marketing team put it in the dashboard, and the rest just happens automatically. This is a technique that many large, well-established companies use, by the way. So I worked at Pinterest and at Google. They have similar in-house systems. Facebook has one too. And what we wanted to do was take that same kind of approach of having this customer engagement messaging optimization dashboard to optimize a part of the notification infrastructure and make it available to all kinds of companies. And we started with push notifications, so mobile and web, and then in-app messages, which are kind of like, pop-ups in your application. And recently, in the past couple of years, we added email and SMS to start to round out our solution, kind of fit our vision of, hey, you can talk to any customer anywhere you want. And in the future, we want to do it, you can talk to any customer any way they want. So you don't decide if they get a push or an email or a text message, they decide. So they can say, oh, I want an email because that's how I'd like it, but maybe they want push or maybe they want SMS. And so we want to be more intelligent, more personalized. And we thought that this was a really important way to get there. So we built out these new kind of channels that we call them. And let me tell you a little bit about how a customer integrates with our system, because we're an infrastructure component. At a big company like Facebook or Google, it's baked into the software. There's no boundaries between the systems, and we have to create those. And so what that looks like is we have these SDKs here, right? This little SDK bit. And then, this SDKs kind of communicate with the customer applications on Android, iOS, on web, and then those communicate with the customer backend. But then we also have our own backend, and there's backend to backend communication. So what I want you to get out of this slide is when you build on top of our systems, there is a front-end to front-end integration, but there's also a back-end to back-end integration. And we produce SDKs, software development kits, for our customers with the idea that that simplifies the implementation for them. So they can simply import our SDKs, get started super quickly. You can handle complex logic, right? Part of the reason people use us is because push notifications are hard. They're a lot more complicated than they look like. And if you don't target the platform APIs, you target our higher level abstract APIs, you don't have to worry about all the complexities with push notifications. You don't have to worry about, okay, what about the next version of Android, the next version of iOS, how it changes. You kind of allow us to handle that. You abstract it away so that we're the ones who are handling that complex domain-specific logic. And it's our domain, right? Nobody builds a notifications app. That's not a thing. You build maybe an Uber app, right? And notifications is just a part of what you have to do. And so by being able to outsource that part of what you have to do to a company that specializes in it, we're able to do that. And a lot of where that happens is on the SDKs. And these top three kind of channels, the mobile, the web, the in-app message, those are very much client-side integrations. So you have an Android SDK, iOS SDK, web SDK. But our new channels, email and SMS, those aren't always going to be client-side. You don't send an email from the app, right? So if you have an order system, let's say you have a drugstore or Amazon, you place an order on the phone, the update of the status doesn't happen on the phone. It happens on the server. And so we needed to start focusing on kind of this server-side integration component in a more meaningful way than we had before. And that's necessitated by these two new channels. And so we already had quite a few client-side SDKs. It's really a core part of what we do as a company, and so this has always been around. But we didn't have any server-side SDKs. If you wanted to interact with our API, you had to use an open source REST API framework or something like this. And that isn't something that is necessarily as fast or easy to use as a custom, specific to the vendor. Like we're a vendor to our customers, so we wanted to do something. And so we started by thinking about what is a server-side SDK to us? What do we want that to look like? What are our requirements? And so we said, okay, we want it to cover top languages as quickly as possible, okay? Lots of email, marketing apps out there, MailChimp, HubSpot, different systems. And we want to be able to build out Python, Java, C++, Rust, C# as soon as we could. We wanted to keep it up to date because we knew that we're still a startup. We're tweaking everything all the time. If we need to change those APIs, we want those APIs to be, those changes to be reflected across all the libraries. We didn't want to have to change the actual API because the system that we had in place, it works fairly enough well. And we don't feel like we have to do that, although there are ways we could have approached this project in a way to change that. We also wanted to make sure every SDK makes sense. Nobody likes a Java SDK that feels like JavaScript. Nobody likes a JavaScript SDK that feels like Java, right? So you want to make it consistent and idiomatic with the language that it's being implemented in. And of course, we care a lot about open source at OneSignal, and so that was something that we definitely had in mind. I know you're thinking, okay, this is impossible. This is a lot of things. If you can get that, maybe you can also get a unicorn, you can get a couple ponies, and some rainbows. I know, it's wishful thinking, right? Well, actually, there's a way to do this. There's a system called OpenAPI. OpenAPI is an initiative, it's an organization, and a set of technologies centered around what's called the OpenAPI Specification. The short version of what that is you have a YAML or a JSON file that specifies what your API is, what it does, and how to use it. Some of you may have heard of Swagger. Has anyone heard of Swagger? Yeah. So it used to be called Swagger. They changed their name. There's a little bit of drama there. I don't want to get into it. But basically, Swagger got bought by a corporate sponsor, and some of the open source stuff became OpenAPI. But Swagger still exists. And OpenAPI, by the way, is actually one of a number of what are called REST API interface design languages. And so these are ways to, again, specify how a REST API is implemented, how to communicate with it. OAS is the most modern one. Some of these other ones you may have worked with if you've been around longer, like RAML and WSDL and WADL and RISDL. They are very powerful, some of the other ones, but they are not very easy to use. There's a reason they're kind of falling out of favor and have fallen out of favor for probably 10 years now. And really, the core of the project is you can take this kind of Swagger or OpenAPI file, the specification file in YAML or JSON, and combine it with either the OpenAPI generator open source tool. Swagger CodeGen is another tool. They're forks of each other, so they're very much related. We went with OpenAPI generator. And that results in API client libraries for all sorts of languages: Ruby, Python, Go, Perl, Lua, Ada, Scala, C#. Anything you can think of, it's there. And it's amazing. Finally, we found the magical unicorn we're looking for. We've got a system that works. Well, let's dig in. Let's see how the unicorn sausage is made, okay? Are you ready for this? Okay. Well, first things first, you need your specification file. And every specification file consists of a set of blocks. The first block we'll talk about is the info block. And this is really metadata. Things like, what is the API, right? Here we have a Unicorn Meatpacking API that you can use to provision Unicorn and related products. And we have specified URLs for terms of service and contact and our licensing and so on. And we also specify the API server endpoint. So this is the place that the actual API communication is sent to. The next block is our security schemes block. So this talks about the authentication method. Different APIs have different authentication methods. We use what's called token-based, which is also known as scheme bearer. So this is an HTTP bearer token. But you can also do, for example, this is a header named API key, right, which is an API key, right? So there's multiple different ways to do it, and OpenAPI provides ways to model all of them. The next block is called schemas. And schemas talks about the objects that you're actually manipulating with the REST API. So here we have a product schema, which is a type of object, kind of like a dictionary in Python or an object in JavaScript. And we've specified the properties. It has an ID, and that's a required property, which is read-only, and it's a string. And this can go on for as complicated, as many properties as you need. And you can also build on top of that. So for example, here we have product. Now we have products. So a product is an array of product. So what you're building out here is kind of like a type system, right? You're specifying the types within your API based off the schema. And the final block is called the paths. So these are the actual endpoints that you'll be working with. So for example, you might send a GET request to the products endpoint, which we'll call a getProducts operation. And what that does is it views all the products, maybe a more specific description. We provide some parameters. Okay, maybe you can specify a limit and an offset, so you can kind of scroll through a list and chunk it at a time. This is a technique called pagination. And we also specify the responses. And so here we're saying if it's a 200, that's a success response. And the content will be application JSON and the schema, and this points to it. And so what this says is when we get products, we expect it to be an array of product objects as defined in the schemas block. And then we also specify the security schemes that are permitted for that endpoint. You might imagine, for example, at one signal, we have endpoints where you can create apps, right, within your user profile. But then within apps, you create messages, you create users, you create other things. And those use two different kinds of keys, right? So you have a user key, which can create and delete apps. Then you have an app key, which is much more limited in its scope. And so depending on the endpoint is which is the correct scheme to use. But here we've just got API key and bearer as an example. Here's an example of how to post an item, so how to create a new product. And you can see here what we specify, a lot like the responses object in the previous block. We have a request body. And so this says it's a post to the product's endpoint. The request body is required, and the schema is the product object. Here's an example of getting a specific item. Okay, so let's say you want to get a specific product, maybe canned unicorn meat, 8 ounces. You can put a product ID there, and this bracketing system will tie it to this parameter here. So it's in actually this should be URL, not query. The name is product ID, and we talk about the schema. Here you can refer to something else, but because it's just a simple string, it just refers to that, and it's required. And it returns a product. Here's an example of a delete. So if you send a delete request to a same path, kind of product/product ID, then you delete that product from the catalog. Okay, so we've built out this simple OpenAPI specification. It's a very simplified form. How do we actually generate it? How do we use it? Well, it's actually super quick. You just, we run this tool called Spectral, which does kind of some linting on the YAML file. And then we're going to go ahead and generate it. So we call OpenAPI generator with the generate function. We specify the generator type, which in this case is Ruby. Our input API YAML file. We specify our output directory. So build Ruby is where the output files are going to go. And then we have the config file, which I'll get into in a second. But wait, there's more. That's not all you can do with these systems. You can do more with OpenAPI than just build libraries. In fact, you can list your API on Rapid API and other kinds of marketplaces based off of that specification file. Retool and other kinds of systems that do kind of API automation and multiplexing, they'll often build their integration off of an API specification file. So you can build integrations with other companies, which helps your company grow with them. And not only can you build client libraries, which is what we've covered here, but you can also build servers, right? So you can make a Ruby server, a Rust server, Python server that is programmatically generated from that API specification. You can make documentation out of it, Markdown, HTML, K6, which is like a tool that does load testing. So you can send that out to output K6 configuration, do load testing. Apache config, you can convert into GraphQL, for example. It's kind of amazing, actually. Once you take your API and put it in a schema, you really want to make it so that's the source of truth. And every system you have that talks to other systems uses the same objects defined from the same system, the same YAML file. And that prevents problems where, okay, this team is building, products, but they have it defined this way, and this team is doing it, and they have it defined this way, and there's lots of bugs, right? So it eliminates entire categories of bugs. I talked a little bit about the config. So this is what the config looks like. And this is additional metadata specific to the particular thing that you're generating. So you note here we have lots of different kinds of generators, client, server, documentation. Well, this is a Ruby client. And a Ruby client, we're going to build a gem, and we have some specific metadata about that. And the consequence then is you get magically generated Ruby. You've got your model objects. You've got your API client library. You can produce a server stub. So you have the little endpoints, but all they do is nothing. You still have to go in and put in the code, okay, put it in the database after you got it or whatever. And it makes all the documentation too. Well, let's say we want to add a new language. Okay, we've gone through all of that. We've built out the spec file. It took us a week. We made some Ruby code. Looks great. Now we want to add another language, right? Because remember, what we wanted to do here was not make one API client library. We wanted to make 10. We wanted to make 10 as fast as possible and as idiomatic as possible. So if we wanted to add TypeScript, all we have to do is add another config, and run the generate with that config, and that's it. Magic. Because once you've built that specification file, you can programmatically generate using that Java tool, the OpenAPI generator, across multiple different languages. And I know you're thinking, okay, it's not all unicorns and rainbows. There's got to be some bullshit that you had to deal with along the way. Okay, you're right. There are some problems that we had to deal with. We did have some existing third-party libraries that were already out there. We had customers that were very passionate about using us, and they made Ruby libraries before we did. They made, Python and C# and JavaScript libraries before we did. And so we had to go out there and engage with them and be like, hey, we love open source, we love you guys, we appreciate what you're doing, but we want to come in and really invest in building this out. And so we had to engage with them and find a path forward to let the customers that have already built with those systems move on to our system. Another challenge we had is keeping API YAML as a source of truth, right? So I talked a bit before about how we want to have schemas ideally consistent across all our systems, because there's a risk of drift. If the client is doing one thing and the server is doing another, and we change the definition of a product, maybe we add a new field somewhere, we have to change 2 places now. And that's really hard to remember to do all the time, right? This team isn't always thinking about what this team is doing. And so I think it's important to keep the API YAML as a source of truth. Once you build a system that is automatically generating off of this, people start to forget that they have to keep these things aligned. Another challenge we had was some specific features in OpenAPI Specification version 3.0 and plus that are not available in the open source tool. And so we actually had to write a lot of this stuff up, contribute it upstream, which was great, but it was part of the challenge, right? We built a system that depends on this open source tooling, but people aren't necessarily investing in keeping that open source tooling up to date. So when we said, hey, as a company, we want to build off that same tooling, we have to invest not just in what we're building, but in our dependencies as well. There's no company I can go to and be like, hey, I paid you guys for this Java tool, and it's missing features. You know what they say? Patches welcome, okay? If you don't like it, send me the code, we'll include it. And I said, okay, we can do that. The other complexity is some of the templates that the system has includes a lot of information that is just not relevant to our use cases. Like boilerplate elements in the templates that are just confusing if you don't understand that this is a thing that is in every single one, right? So we had to go in and tweak some of the templates to remove some of those confusing aspects. And looking forward, like I said, what we want to do is continue to move towards having that specification file as a single source of truth. We want to generate documentation off of it. We're still not doing that. And we're also not really doing a great job with API test cases. We've built out these libraries, but we're not being as comprehensive with testing them as we need to be. We do have, by the way, just so you know, we have Ruby and Node.js. We're kind of the first few that came out. And since then, I've actually got quite a few more rolled out, so I'll walk through some of this code now before we move into Q&A. So this is what the API client libraries looks like today. So we have a system here that's all automated. We use this build script, and we pass in the specific language that we want. And this, in turn, calls OpenAPI generator. We had to have we have Git subtrees for all of our inputs, so the actual specification file and the generator itself. And then we have subtrees for the outputs. So coming down to these linked repos, we have these 2 inputs, the OpenAPI generator Java program and the API specification file. And then we have outputs, Ruby, TypeScript, Go, Java, .NET, C++, and Rust. And I'll show you. So this system has been in place, and we've shipped originally just Ruby and TypeScript. And then about 6 months passed. And then we did Go, Java, .NET, C++, and Rust. All of them we built in the span of 2 months. 2 months. Right now, I have an intern working on the team for the summer. His name is Mario Reyes. I want to show you what his work looks like, because it's almost done. He's adding Python. And this is all it takes, okay, at this point. We have an automated system, so he inserts the Python-specific testing and setup scripts. This is part of our CD system, so it continuously deploys as we make changes to the specification. GitHub Actions kick off. We don't even have to run this stuff anymore. It's all on GitHub Actions. And once we make one change to one thing, we get 10 PRs, one for every language. We just click, approve, land it in, and it's super fast. And this is part of how we do that. So here he's adding just the line to the README. This is not. So part of, as we build out these different languages, what we're discovering is some of these languages are weird and they behave different ways, and they result in us having to change our specification. So we've discovered, for example, that Python nullability is important because of the way Python works. It wasn't important for .NET or C++ or Rust or Java, but having this specification in Python was important because of the way that system works. So that was a change he had to make. Here is the Python CodeGen YAML file, super small. This is a telemetry header, so we pass in just version to an API header so we can track who's using it. And we do have a unique authentication system, so we have to sometimes make changes to that. I think earlier I talked about app key and user key being different, having different security schemes for different endpoints, and so this facilitates that. And then after that, it's super simple. Basically, all that happens is we have a handful of lines. This boilerplate build script, which just says, okay, once you've built out this build Python directory, how do you actually turn that into a tarball or something we can deploy up to PyPI? And just a little bit of glue code and a test script. And that's it. This guy wrote 230 lines of Python to test out the system. And after all of this is done, we have an intern who's been working for 3 weeks. And we have a brand new Python library, top of the line. And when he's done with this, he's going to do PHP. It's going to take him 2 weeks. I guarantee it. Because once he's learned all this stuff, it's not that much harder. The bulk of what you're actually doing is just this test script to test the endpoints and validate that what's being built works. So we have this kind of system now that enables us to release new languages on the span of 2 weeks, that enables us to update across all of our languages in the span of 2 minutes. And we've built something that is idiomatic, and because it's built off of template files that are specific to each language. And if we find something we don't like, we can just go upstream into the OpenAPI generator source code and actually fix it. Super simple. We have our own patches, tweaks that we've made to some of the templates. But let me show you a little bit about what those files actually look like. This will load. If not, I can pull it up in here. Come on, Wi-Fi. Okay, well, while that's loading, oh, look at that. Okay, while that's loading, let me talk to you a little bit about our automated system. So we have these 3 kind of GitHub actions. One that does testing, one that does deploy, so continuous deploy, so it submits downstream pull requests. So here's API client library dependency update. So this is the third kind, which says, okay, all the inputs into our system, we want to keep them up to date. This is actually part of how, we have this separate API JSON in a separate repo. That's part of an input. But so is all the outputs. So we calculate, part of the reason we do this is because we need to figure out what files were deleted. And Git doesn't make this very easy to figure out what files are deleted. So we actually have to preserve the outputs in this repo so we can calculate what things need to be deleted, so when we submit those automated downstream PRs, we can handle that. Looks like the Wi-Fi is back. Let's jump in and see if I can show you. Maybe not. There we go. So this is the OpenAPI Generator open source project. We are a sponsor, by the way. And we just recently had 6.0.1 release. And this thing gets a lot of activity. So this is lots of folks around the community working on this thing. Because we're not the only people using this technique. There are other companies doing this, like Datadog and API Deck and other folks who aren't sponsoring, who are also using this system. And they often push things upstream. On the core of the source code, I'm going to jump into modules here. The core of the source code, beyond the infrastructure bits related to it, are two components. The first is called the template files. So let me pull up PHP template files. It's a series of mustache files. So here's the API. And this is just a mustache. So you talk about the partial header. Here we have our classes. And it's just interpolating strings. That's it. But it does it in a way that's very PHP kind of specific. And, you don't have to write all this stuff. You can leverage the existing open source system. That file is paired with a business logic file specific to PHP. I'm going to pull this up here under the languages. There's the PHP codegen.java, PHP client codegen Java. And so this is just any of the PHP specific stuff. It's pretty lightweight because it's built on top of abstractions. And so with the OpenAPI generator, when we actually find problems with our system, all we have to do is tweak these two files, and that's it. We can put it in our fork. We save those changes in our fork, and we can submit them upstream, and upstream can take their time to review them and import them, because there's not that much that we need to know. We don't dig into how is the programmatic execution happening. For those of you who don't know, the process is actually very similar to a compiler. Technically, what you're doing is transpiling. You're transpiling from one language to another. Well, I guess you're compiling like template files and the JSON file into some code. And so the actual mechanism is a lot like a compiler. And so we don't want to necessarily have to dig into that complexity. We want to focus on the parts of the problem that are specific to us. And that's the benefit of the strategy. It's a technique that we've used to success. We've done this to have a system that enables us to roll these new API libraries out super quickly. We can update them super quickly. We can keep them going forward on an automated basis, and we don't have to invest heavily in having a big team support it. If we had decided, let's make a Python library, let's make a PHP library, let's make a JavaScript library, let's make a C# library, let's make a Rust library, it would take, what, 8 people, right? Months to roll it out by hand. And we did this. One guy, 3 months, did 5 of them. One guy is going to do, in 2 months, he's going to do 2 of them. An intern, right? It's not super complicated. We've simplified as much as we can. And so this technique is part of what we do to be able to provide a customer experience to our developer customers on all these languages as quickly as we could, so that they can send SMS and emails very simply. They don't have to they can use an approach that's simpler and requires less effort on their behalf. And by using this technique, we're able to do all of this super scrappy, super quick. And that's necessary because for us as a startup, we have big companies that are rolling out our same product, right? And they have existing customers that they want to compete with us. And then we have smaller startups nipping at our heels who are building out new features faster than we can because we have big customers. We have customers like MLB, NFL, USA Today. Lots of companies all over the world use us. And so when we change our systems, we can't just move stuff around super quick. We have to be thoughtful and intelligent because we don't want to break anyone. Anyways, that's the thing that I want to share with you today, this technique of procedurally generating client libraries from a specification file. And I hope this helps explain how we are able to use this to strategically differentiate ourselves amongst our competitors. Any questions? Yes?
My question is regarding the business logic.
Okay.
How do you guys manage to put that business logic in the specification file?
So the question was about business logic and how to put the business logic in the specification file. And the API client libraries that's built out, all it is it's glue code between the caller and us. And there is no business logic. We just have dumb model objects, product object, user object, so on. There's no action taken on it. For the client side, all you're doing is taking the object and sending it over. On the server side, if you do a server-side generation, that's where you have actual business logic. You need to figure out, okay, I've got a product object that's changing. How do I change it? What does it mean to change? And so when you have the programmatic server-side generation, it basically is a little stub. So you just get like a little endpoint stub. You got to go in and write all the code yourself. So there's no encoding the business logic in the specification because the specification only specifies how to pass objects. You still got to write that code in that business logic in your server-side code where appropriate. Yes? Yeah, that's a complicated one. Basically, in the early days, we had, when we were first building this out, we called it a beta. And so we didn't really care that much, right? And stuff was breaking all the time. But now that people are using it, they're depending on it, we have customers that are integrating with it. We have to be thoughtful breaking changes. If we change an endpoint in a way that makes it so that it doesn't work the same as it does before, customers can't just, click dependabot, update, no big deal, and think everything's okay. We have to actually call out what changed and why. And a big part of how we do that is with a technique called semantic versioning. So we basically just say, hey, this is a breaking change. You should be aware of it, and you need to think about what are the specific ones. So the answer is basically a combination of semantic versioning and migration guides, documentation, customer communication. We do have plans to do certain kinds of migrations that are very complicated and like if we have a big breaking change that's very complicated to do a migration for, we have a CLI tool. And we have plans to build that CLI tool so you can say, okay, run this CLI tool, migrate from version 1 to version 2, and that simplifies the process. Because basically, you start with a documentation, which is like, oh, you have a breaking change. Here's the 10 steps to follow to deal with that. Well, now you have 10 steps. You just go in Python, you do step 1, step 2, step 3, step 4, and suddenly you have a tool that people can use to make the breaking change easier to deal with. You're never going to be able to remove the developer having to think as part of that process. That's the nature of breaking changes. But at least we can make it easier when that happens and reduce when it happens. And in particular, make sure that it doesn't happen on accident. Make sure that people know it's happening. Because nothing is more frustrating than opening up Android Studio, than opening up Xcode, than opening up VS Code, clicking update dependencies, because, of course, everything's got 5 updates a day, and suddenly something's broken. That's not what people want. They want things to work. They want to know what's going to change and why and make sure that they can handle that. Yes? Yeah.
I have a question about how do you provide like a custom template for one specific language when you are running the generator tool?
So the question was how to provide a specific template for a custom language.
You want to change, for example, the naming convention or maybe some dependency in one specific library.
Yeah, let me see if I can find an example of how we do that. Is this an example? No. Actually, I can go this way. So we have inside of our repository a set. It's separated into inputs and outputs, and our inputs are our API JSON file, the code generator. Actually, I don't know what the hell this is. OpenAPI generator, that's the code generator, and then a set of static files. And the static files are things like license files, where it doesn't need to be generated, but we need to add it on top later. But if we have to change the stuff that's generated, basically we just go into that directory, into these mustache files, and just tweak them, and then we land them in our own repo. And we have a git subtree command that will keep it updated. There are times where you might want to add a new language, for example. This system is really extensible, OpenAPI generator. If you wanted to add a new language, you have to add basically a new, what's called client code gen class. This is the one for PHP. You can see it's pretty small. This one actually extends from an abstract one because there's multiple kinds of PHP code generators. And maybe you want to make a new PHP one that uses advanced experimental kind of PHP libraries. You can make a new experimental PHP code gen, extends from that, and have your specific overrides, and in particular, these template files. And then you simply go, and here we've got the PHP templates. You can just go in and tweak them, right? So you have your model object here, and this refers to all the classes, and it just pipes in model generic. We pull that up here. And so it's just a set of files that, okay, let me see if I can find an example. It extends the schema, it implements, if, here we go. List properties, and then the functions. So these are getter objects in this container. So it's all like, it's simple to the point where if you want to, you can just copy something that already exists, make it a new set of things, and then tweak it. Or if it's something where you want to go kind of from scratch, a brand new language, maybe you want to add a language that's not there, it's probably a few hundred lines of Java and just the template files. And that's basically it. Yes?
Let's say that you add some new properties to your one single schema API.
Yep.
How the different generator accept those changes? I mean, how does this affect the different generators that you have? You have to change something there?
So I will show you. So the question was, if you change a property, the schema, how does that change the generator? And the answer is, it depends. So here's an example. We had an iOS attribute, is iOS, that was used to always be default true. We decided that that actually was a mistake. It shouldn't be default true. So we changed it. And all we had to do on our side was just change our tests, so we're no longer confirming that it's set up the way that it is. But there's no change that we have to make to the template files, no change to anything, because it just takes in that schema file. And these mustache templates in here, they have properties that have, like, is nullable, true, if not, false, right? It's already built out so that it works off that same layer of abstraction. We added a new property recently. I'm going to see if I can find it. These pull requests are not going to be loading easily.
So no changes are needed if you change the schema you can edit?
Not at all. We change the schema, and we just click a couple buttons, and everything happens. No changes needed. Yes?
How this handle the combination between several modules in the same API? For example, if you have like an endpoint that is going to be used in several modules to get the right functionality.
Yeah. So the question was, how do you handle cases where it's not a simple kind of, okay, this is add user, create user, but maybe you have a more complicated endpoint that pulls in multiple model objects? This is our API JSON file now. This is what it looks like. It's very long. And I will show you some of these higher order objects that we've built to deal with what you're describing. So we have, for example, a notification target that is any of a segment notification target, a filter notification target, or a player one. And then we have a notification object, which is actually a notification target, but then also all this other stuff, these other properties. And some of those are, referred to other schemas. And so the short answer basically is you create objects that are built on top of the existing objects. And sometimes you have to make names for stuff that's stupid, right? We have a string map, which is actually just like, okay, what about, if we have a message in English, Arabic, Bosnian, Bulgarian, Catalan, we have this string map object. Nobody actually uses the string map type, but it's part of an object that's used across multiple endpoints. Does that answer your question? Any other questions? Yes?
Are you generating that JSON file, or is that something that's running manually?
It took me 2 Red Bulls and 2 afternoons, and I wrote it, and it had a lot of bugs, and the interns helped us find the bugs. Yeah. But once it's done, it's done. So now all we have are small updates to it. So we have an open pull request now for this, new delivery stats that we want to add. And it's just, hey, we have a new kind of, in this schema, platform delivery data schema object. Now we have new endpoints for SMS and for email, which include these higher order things. So this person, Des, who wrote this, she's on our product engineering team. She doesn't touch any of our SDKs. Guess what? When we land this, our SDK team doesn't have to do anything either. They can add the test if they want to confirm that it's working, and in some cases we might want to do that. But at a certain point, it's overkill. The object is going to come in with all those properties. I don't need to write something confirming it in every language. So that it is something that has to be written manually at first. There are, if you already have something in one format, you can convert it. But you got to write it in some specified format. But once it's there, it's super simple to write the lines out. Any other questions? Okay, great. Thank you all so much for coming to the talk. Hope you enjoyed it.